Good morning, everybody. My name is Korra Kiran, and today my subject is thermal engineering system. Here we can see that my topic name is compression ratio of petrol engine, and here we can observe that introduction to compression ratio. The compression ratio is a key parameter that affect engine performance. It is defined as the ratio of total cylindrical volume when the piston is at a bottom dead center to the volume when top dead center. Understanding the compression ratio helps in optimizing the efficiency and power output of a petrol engine. Here the compression ratio is nothing but it is the important parameter in the performance of engine, and it is defined as a ratio of cylindrical volume and the piston of bottom dead center volume to top dead center. I'm sorry. And other thing is uh, definition of compression ratio is nothing but the compression ratio is expressed as a numerical value such as 9 is to 1 or 10.5 is to 1. This is the expression of a numerical value of compression ratio. At the same time, it indicates how much the fair fuel mixture is compressed before the ignition. A higher ratio generally improves thermal efficiency but it can increase the risk of knocking. Now, how compression ratio is calculated? The formula for compression ratio is V1 plus V2 by V2, where V1 is the total volume and V2 is the clearance value. We know the formula of clearance is pi by 4 into d power 4. It's nothing but we can calculate this clearance value. And at the same time, the clearance volume is the space remaining in the cylindrical when the piston is at the top dead center, and precise measurement of this volume is essential for accurate calculation of the compression ratio. And also we can observe here typically compression ratio is petrol engine. Most petrol engine have compression ratio ranging from 8 is to 1 to 12 is to 1, and also lower ratio are used to prevent knocking in high speed or high load condition. Higher ratio are employed in modern engines to enhance efficiency and power output. Now we can see that. Now we can observe here efforts of increasing compression ratio. Increasing the compression ratio improves the thermal efficiency and fuel economic. By increasing the compression ratio, we can also increase the efficiency of thermal and fuel economic. At the same time, it leads to a more complete combustion process, resulting in better power generation. And also, however, excuse ratio can causes knocking and engine damage if not properly managed. If we are not properly gaining the resultant better of a compression ratio, it may damage the managing of the properly. And here we can observe that knocking and it is relationship with compression ratio. Knocking occurs when the air fuel mixture auto ignite permutually in the cylinder. Higher compression ratio is increase the tendency of knocking to occur. To prevent knocking, fuel with higher octane rating are often used in engine with a higher compression ratio. And also we can see here advantages of a higher compression ratio: improved fuel efficiency and reduced fuel consumption, and increased power output without enlarging engine size. Better thermal efficiency contribute to lower exhaust emission. Here the advantages of compression ratio is nothing but one of the is we can improve the fuel efficiency and we can reduce the fuel consumption. And also one more thing is power output can enlarge the size of the given fuel of consumption. Now we can see that limitation of increasing compression ratio. Higher ratio can lead to knocking with which damage engine component. Material limitations of engine part restrict how high the compression ratio can be set. Advance in fuel technology and engine design help mitigate some of this limitation. Techniques to achieve higher compression ratios. Using high octane fuel to restrict knocking at higher ratio. Employing turbocharging or supercharging to improve the overall efficiency for the compression ratio. and implementation advanced engine management systems to optimize the combustion. And modern tends in compression ratio design. Modern petrol engine often features compression ratio between 10 is to 1 and 13 is to 1. And variable compression ratio technology allows engines to adapt for different driving conditions. In different conditions, we have the compression ratio through the allowing the engine adaptation. That is the one thing. And engineers continuously seek to balance high compression ratio with the engine durability and the fuel economic. Now, summary and key takeaway means here the compression ratio is a vital determining the engine efficiency, power, and knocking rhythm. Actually, the compression ratio is one of the important of efficiency of engine and power and knocking the tendency. That is the one thing of compression ratio. And higher compression ratio generally enhance performance, but require careful design consideration. Technologically advancement and the continues to push the limits of achievable compression ratio in petrol engine. Here we can observe that what we are learning in this session. Here the topic is compression ratio of a petrol engine. Introduction to compression ratio is nothing but it is the very important or it is a key parameter of engine performance. Because of that, it have the ratio of optimizing the efficiency and power of petrol engine. And we can define it by the help of the numerical value such as 9 is to 1 or 10.5 is to 1. And also it is indicate the mixture of air fuel, and we can calculate with the help of the formula V1 plus V2 by V2. Here V1 is nothing but total volume and V2 is the clearance volume. Now the compression ratio in petrol engine is it ranges 8 is to 1 to 12 is to 1 in most petrol engine, and lower ratio is it is mainly prevent knocking of high speed to or high load. And efforts of increasing compression ratio is it have the thermal efficiency of fuel economic, that was the one thing, and combustion process. And knocking and the relationship with the compression ratio is nothing but it have the air fuel mixture of the knocking occurs, and at the help of the prevent knocking fuel which can a high octane rating are often used for the compression ratio. Now, advantages of higher compression ratio. What are the advantages? Nothing but it have the improve the fuel efficiency and reduce the consumption. At the same time, it can increase the power output without enlarging the size. Without enlarging the size, it can increase the power. That was one of the advantage. We can see that. Now, limitation of increasing compression ratio. Here that it can damage the engine component if the it can if the compression ratio can have the lead to knocking, then automatically it can damage the engine of a component. That was the limitation. And other thing is it can restrict the compression ratio to the set the material engine part. That is also one of the thing. Now techniques to achieve higher compression ratio is nothing but it have the high octane fuel. That was the one technique. And other than this is it have the turbocharging and supercharging to improve the overall efficiency. For the technology techniques, we can increase the efficiency and we can improve the efficiency through the help of employing turbocharging and supercharging. Now, modern trend or compression ratio here is nothing but we can see in the modern petrol engine, the compression ratio range is between 10 is to 1 and 13 is to 1. Now, one more thing is it engine can allow the different driving condition through the techniques of the compression ratio. Now, here the summary and key takeaway. Here the main summary of this key is nothing but the compression ratio is vital for determining an engine efficiency. Actually, it is vital means nothing but it is important. For compression ratio have important to determine the engine efficiency and power and knocking tendency. For these three purpose, compression ratio is very important. And other than this is higher compression ratio generally enhance performance but require careful design consideration. Actually, compression ratio have the performance, but we need to design it carefully because of it have the efficiency and power and knocking the tendency. Through this, we need to carefully design the consideration. Right? Technologically, advancement continues to push the limits of achievable compression ratio in petrol engine. In petrol engine, we need to technologically advancement and we need to push the limits. In the push, we are by through the pushing the limit, we need our engine, either it is achievable or it have any other than behind the boundary or the limit, we need to think, and after that we can change the compression ratio in petrol engine. Conclusion: optimizing the compression ratio is essential for developing efficiency and a durable petrol engine. Through the compression ratio only, we can see our either the effici- either the development of essential efficiency or there or not. Through the help of the compression ratio, we can validate it, and it have the ratio with the fuel quality also. And also one more thing here we need to notice, that is it have more efficiency automotive engines because of the ongoing research. They can improve the compression ratio, and it will definitely be leading the more efficiency ratio. And this is the last slide also, and thank you.